Well, good morning everybody. Good morning everybody. Today on the workbench I've got this old ahev signal generator, and for the people playing along at home, it's an Advanced and the model number is type J1B. Now, why did I buy this? Because I've got lots of more modern signal generators. Well, the answer to that is a predictably stupid one. The reason I bought it is because it was £5, but I was also wondering if it would have a good output, you know, a good undistorted output, because most of the modern signal generators I've got, although I have got some transistor analog ones, the one that I mainly use is a modern DDS signal generator. So I just wondered if it would be worth getting, you know, an old analog signal generator and seeing if the output was particularly clean and undistorted. I suspect it won't be, but that was the idea. And as I say, the main reason I bought it is for £5. So it's got one of these quite nice, I think you'd call it a slow motion dial. It feels like there's a clutch in here, so when you turn the knob rapidly, the scale increases quite quickly, but if you turn it slowly, you've actually got a range of motion here that allows fine adjustment. So what ranges has it got on? Right, okay. It's got from, it says a range from 15 cycles to 300, 300 cycles to 4,000 cycles, and 4 kilocycles to 50 kilocycles. So there's none of this modern hertz business. We've got everything in kilocycles, and we've got various outputs here. Yeah, what can you say? It's got various outputs. But the other interesting thing is it's got 2 separate output connectors, and these have got obviously different output impedances. It says that this one here is 4 ohms, and sorry, this one here is 5 ohms, and this one is 1600. Now, I think the seller that I bought it off said it didn't work, and that's fine. I mean, I didn't really expect it to work for £5. Has it got anything on the back? Oops. Oh, it's got a PAT sticker on it. PAT sticker, let's see. It was last PAT tested in 1997. And it's got some more information about it on here. It says it's Advanced Electronics Limited, Hainault, Essex, England. It's LF signal generator, type J1B. Mains power supply 105 volts to 125 or 210 to 250 volts. And it will work between 40 and 100 hertz mains input cycles, and the serial number is number 900. And just looking inside it, I can see a few valves in there, so yeah, £5, it was worth it for the valves and the transformers. I'm kind of wondering if this has probably come out of a school or something like that, because this handle on top looks as though it's been repaired at some point, and this feels like an old bit of tubing that you would find in a Bunsen burner. So I suspect this has come out of a school. Now, the other thing about this is it's got this it's got this really quite disgusting plug on it, which I absolutely love. It's got a wonderful patina on it. And I'd almost have a pound with you guys. I bet when we plug this in, even if the wire is okay, I bet it fails its PAT test, because I can just see the amount of tarnish on these connectors. It'll almost certainly fail. So I'll tell you what, boys, we'll have a pound bet on that. Mains cable. It's a rubber cable, and it feels a little bit funky. Now, it hasn't totally degraded yet, but I would have thought probably replacement is, you know, something that should be considered. It's definitely on its way to having that kind of soft, rubbery, funky feeling. Let's just leave it at that. Now, normally when you've seen me doing PAT testing, we've been using my my Evo tester, but just for a little bit of a change, I've dug out this Claire A255. Now, again, this is another of my eBay buys, and it seems to work okay. but I don't use it very frequently, which means that I can't really remember how to operate it, so that's always a good start, isn't it? The other thing about this is before I got it, the control knob had fallen off and somebody had replaced it with this knob. This knob has been off and on that many times. This pointer that on it bears absolutely no resemblance most of the time to the function that we've actually selected. So yeah, it's all very hit and miss, but yeah, that's what you've come to expect from me, isn't it? Well, stupid me's just spent about 5 minutes trying to figure out how to switch this thing on. It has got an on button there, and I was pressing it and nothing was happening, but you've actually got to press it in quite hard because it's more than a button. This is actually one of those thermal magnetic circuit breaker jobbies. So let's switch that on. Right, so we're going to plug our signal generator into there. 0.1 ohms earth circuit test. So I think that's going to be earth continuity, isn't it? So what we've got to do is we've got to find a piece of bare steel work on here and connect the test lead like you've seen me do on the AVO unit. So it's a matter of trying to select something that we think will be earthed. I guess it doesn't matter what we select because any piece of metal on here should be earthed. If it isn't, then it's a potential safety issue. Oh, I'll tell you what, that's riveted on. That's got to be worth a try, hasn't it? And I believe we just press the test button now. I do like this tester because it's got lamps on it. You can't beat dial lamps, can you? I mean, it's all very well having LCDs and things like that, but look at that. Look at just the glow of those orange lamps. That's so just so sexy. I mean, yeah, you can tell an idiot is easily entertained, and I'm an idiot. Nothing happened then. All right, okay. Turn it to circuit test. Press the button, and it fails. Okay, maybe that's a particularly crap piece of metalwork we've got it connected to. Let's try and find something better. Let's try again. Total fail as well. Okay, so if I've got everything set up right, which I may not have, that's totally failing. So I wonder why. Okay, we've got the meter set to our continuity beat function. So let's just confirm that that works. Yep. So let's go off the earth pin. Okay, well we have got an earth connection there, but as you can tell it's rubbish. So you can see that this plug is, the connections on it, I'm hoping you can see that, are just really, really grubby. And looking at the age of the plug, you can see, I think this would probably fail an inspection and a pat test anyway, because the type of plug is banned now. Because if you look at a modern plug, which I'll find in a second, the pins have got an insulator placed over the pins, but this is such an old plug that it doesn't have that insulator fitted. So if I was to reach and pull this plug out, what I could do is, while it's still plugged into the socket, I could kind of reach round and make contact with these live pins. But if we look at a modern plug, let's unplug the tester. You can see that a modern plug, if it'll focus, come on focus, a modern plug has these plastic shrouds, so that if I was, the idea is if you did manage to, well, it's hard, the body on this plug is wider, which is safer in itself, but you can see that the actual live and neutral connections have got these plastic shrouds on them, and the idea between that is if you did manage to kind of accidentally reach round, it makes it, well, it makes not possible but almost impossible to get your fingers on the live connections, where, to be honest, it would be very easy to get my fingers on these live connections. So this plug needs replacing. It should be banned, but to be honest, I quite like to keep it because let's face it, if I electrocute myself, it's fine, and yeah, it keeps life interesting. So the question is, are we failing because the resistance of these of this earth pin is just horrible, or are we failing the pat test because it's something wrong with the lead or the connections inside the plug? Well, the first thing we'll do is let's just try cleaning the earth pin. So let's just have a go at cleaning these disgusting earth pins. Just going to use a little bit of spray contact cleaner deoxit, and also on top of that I'm just going to use some fine emery paper. God, it really is very dirty, this thing. Yeah, I think that's looking a lot cleaner. I think before we plug it in though, let's just have a look inside it and make sure that the earth wire is connected, just because you never know, it might not be. Oh, let's play the what fuses it got in it. I think this has probably come from a university or a college, so I suspect it might have a sensible fuse rating in it. Shall we? 1, 2, 3. Yeah, 3 amp, not so bad, eh? Okay. I do love playing the plug game, the plug fuse game. Yeah, that feels tight. Okay, let's plug back in. Switch on. Just put it on standby. Switch on. God, love those lights. Earth continuity test. Does it pass? Oh. In fact, let's whip the cover off and see if we can find a decent piece of metal. Now, I'm going to very carefully take this screw out, and what I'm going to do is I'm going to just throw it on the floor. Because what always happens is whenever I pull something apart, I always lose one screw. So if we actually get that bit over and done with first of all, then we shouldn't have a problem, should we? Right, will that come off? It looks as though this should just slide back, but I don't know. Yep, looks like a typical signal generator of its era. Built like a proverbial brick toilet. Nice thick aluminium castings. Can't really see what all the valves are. EZ81, that's a rectifier, isn't it? Couple of transformers there. I wonder why there's 2 transformers. I wonder if... No, well, there's actually 3 transformers in there. I was going to assume that one of the transformers might be an output transformer. It could have been that one of the transformers had been a modulation transformer, but there isn't any external modulation on this, I don't think, so I wonder what they're for. I don't know, maybe I'll have to find out. Yeah, I don't know. I can understand 2 transformers, but why is there 3? Maybe one of them's a choke. Well, it's not wide as a choke though. I don't know. Maybe have to find that out, won't we? Right. We should get a better connection off the chassis here. And if this doesn't work, I'm going to show my arse in Burton's window. Oh, look at that! I've just spotted some little thermistor bulbs there. That's obviously used just to keep the output level constant. I do like that. Nice little touch. Tip me onto your front gently. Come on, baby. This should pass. Surely this is going to pass now. Pass. There we go. But obviously there wasn't a very good contact between the chassis, which is earthed, and the actual cover of the equipment. I think if we put this back on, what we'll probably do is we will actually fit a separate flying lead with an earth cable between this back cover and the chassis, because it has to be safe. Whatever we do has to be safe. don't know why I'm saying that after I said I'm going to use that crappy old plug, so I obviously don't care about safety. Oh, now looking at this, I can just see some gunge in there. So, is that gunge? Yeah, there's something oily in here. I wonder if these capacitors are filled with oil. I've never actually seen a capacitor and that leaks like that. I know electrolytics and things can leak, but yeah, it's got goo on it. So I'm suspecting that something is amiss. I'm saying I suspect it's leaking because I'm kind of wondering with it. You know, you never know with something as old as this. Is it actually leaking, or is it just some goo that's been poured into it while it's been stood in a cupboard somewhere? But yeah, it's kind of a thick, oily, gooey consistency. I suspect that is some electrolyte that's leaked out. So maybe we need to replace some of them before we switch it on. It looks like that's some form of coupling capacitor, coupling maybe the output from one valve to the grid of the next. And if they're leaking DC, the last thing that you want to do is switch it on, because you know, you'll just light up the output valve. Let's put it on the 500 volt insulation test, which is twice the operating voltage, and press the button and we'll see if it passes. And it passes that as well. So regarding the safety testing, yeah, it's passed, that's fine. So we'll put the pat tester away and decide what we're going to do next. So we're just looking at the top side here, and I said before, it's got two transformers in here. So, well, it's actually got three. It's got two transformers here, and it's also got a transformer under there. I've not had a good look at them. They might not be transformers, but I was going to say one of them might be a mains choke, but they look as though they're wired like transformers. And I've got everything unplugged. Yeah, this is obviously the main primary transformer, because it's got instructions here about what voltage tapping to use, so you can use it on, by changing the tappings, it looks as though you can use it on 105 to 125, or 210 to 250 volts, which is what it's set to at the moment. So that's obviously, that must be the mains transformer. We've got a mains fuse here, which I'm guessing is on the primary side, might be on the secondary, I'm not sure. Got an EZ81, again EZ, don't know what the 81 bit, but I do recognise the EZ designation, so that's going to be a rectifier. Oh, we've got the ubiquitous EL84 valves, a 6C4 and an ECC88. Looks like there's some adjustment potentiometers there. Turn you over. So here's that other transformer that I've said I'm not sure what that does. Here's some thermistors, which is there to actually give it some level control as the things warm up. I'm guessing this changes the I don't know if it changes the bias, but it certainly changes. It's designed to keep the level constant. These are the some adjustment pots here. Again, don't exactly know what they adjust, but they obviously adjust something. Good, look at these old kind of dog bone resistors. I thought this was a lot more modern than that, to have these style of resistors in it, because it's got, you know, the relatively modern like 1960s resistors in there, and then it's got these big dog bones. So yeah, seems a bit of a, I don't know, a bit of a difference in age of components. I mean, they look like something out of a 1930s receiver, and they look like there's got a resistor behind it just tucked away. That looks much more recent. Well, I say recent, it was like 1950, 1960 or something. But I don't know if you can see, there's some, this is the goo that I'm talking about that's certainly on top of that capacitor there. And there's some goo on that one. So it's not clear whether or not that goo has, where it's come from. Yeah, not sure. Yeah, definitely gooey. The capacitors themselves, you know, look at the ends where the goo would have leaked from, they look dry. There's no obvious signs of something leaking. So you never know with some of this. This could just be stuff that's tipped into it. I'm guessing the thing to do is they're probably going to want replacing anyway. They almost certainly are going to want replacing. Just seems odd because the goo is on the outside of the capacitors rather than being on the inside. I mean, sorry, I know I know you're going to see it on the outside, but it's like a plastic covering over the capacitor, and you know, it's actually the end caps. If it was leaking, I would expect it to be coming out of the end caps. Actually saying that, yeah, there is some goo under that end cap there. Feels like everything's wired in solid wiring. Right, we'll change these out because there's no point in not changing them out. I can't tell if they have leaked, but there's definitely something. Like I say, I can't tell if the goo on these is something that's leaked out of the capacitors or maybe something that's just poured into it, some oil or something over the years, but I'm guessing it's a smoking gun. If I don't change them out, I'm stupid, so I'll change them out.